The mean for a data set is nothing more than just the arithmetic average for a data set. So if we were to find the mean for this data set, all we would do is we would add these values up. If we add them up, it's going to add to 100. And then we would divide by the number of data values that there are. Well, we need to get some notation that describes what all these things are. We talked about the data values. Well, we need to have some sort of a variable that describes data values. Well, the variable that we'll use will be x. So the x values will be the data values. And if I add them up, really what I'm doing is I'm finding the sum of all of these x values. So this capital sigma right here means sum or add them up. So the sum of all these x values is 100. If we added all these up, we'd find 100. The number of data values in a data set, we're going to use the letter n for that. So if we count them, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 values. So to find the mean then, we're just going to take and we're going to divide the sum of the data values by the size of the data set. So that's going to turn out to be 100 over 15, which will be 6 2/3 or 6.6 repeating. Now, it then starts to occur to us, well, maybe it's important how we round this mean, and it is important. The rounding rule for the mean is to round to one more decimal place than occurs in the raw data. Okay, so our raw data is just the data values that we haven't done any calculating with, just the data values that are recorded. And these are all whole numbers. So when we round this mean, then we should round this mean to our tenths place. One more decimal place than occurs in the raw data. So that would be 6.7 then. But it is important what notation we use for this mean. We've got a notation for our data values. We've got a notation for the size of the data set. Well, we need a notation for the mean. It also then starts to become important for us to differentiate between population values and sample values. If we report our mean as a mu, in other words, we use this Greek symbol mu for mean, then what we are implying to the reader is that this mean was calculated from a population data set. If we use the symbol x bar, then we are conveying to our reader that this mean was calculated from a sample data set. And it's very important to differentiate between the two. If we have population data, then we can make perfect decisions. With population data, we can generate measures that will allow us to make decisions that we don't have to question at all. We don't have to compensate for any kind of sampling error. But if we have sample data, then we're not examining every object in the population, which means then that we are using techniques to make estimates and introducing the possibility of sampling error. So that conveys to our reader that you proceed with some caution when you use these measures. In either case, the calculation is the same. You take the number of data values and you divide it into the sum of those data values. So it's going to be 6.7 when we report it rounded properly in either case.